This is a solutions video for STAT chapters 7 through 9, fall 2013, and there was 53 points in this test. I did not curve it in, but I did take every score out of 50. So if you miss 3, essentially it's 100 points. So on the first one here, it's a hypothesis test with proportions. They think the proportion is 13%. You're testing the hypothesis to see if it's not 13%. So the null hypothesis is that the population proportion is 13. The alternative is that it is not. So it's a two-tailed test. Calculator Z statistic here is 1.82. And then we look that up in our Z table and find out the area to the right of that is 0.0344, but we double it to make it 7%. Some people forget to double it because it was two-tailed. If you did do it one-tailed, I think I was okay with that. But in the way I did it here, since p is greater than 0.05, we do not reject. This is not a rare enough occurrence to reject the null hypothesis. So that means there's not significant evidence. The proportion of single-parent homes is not 13%. So we don't have enough evidence to say it's not 13%. So type 1 and type 2 errors. Type 1, we would reject the null and say the proportion of single-parent homes is not 13%, but when it really is. And the type 2 would be not to reject the null and say, yeah, it's 13%, but it really isn't. And then here's the 95% confidence interval. P hat was 17%. There's our z-score we use for 95% confidence intervals, standard error. And so we're essentially would say we're 95% confident the true proportion of single-parent households is between 12.2 and 21.8%, and the question is 13% in there? And yes, it is, which kind of backs up what we did with our hypothesis test. And number 2, this is testing the average lifespan of engines. It's assumed that it's 220,000, and we're trying to see if it's greater than 220,000, so it's a one-tailed test. Calculator T statistic, we get 6.45. It's a really large T-score, and if you look it up in your T table, under row 9, it's off the charts really. So obviously the p-value is way less than 0.05. The p-value is almost 0. They're that far away from what we thought. So we reject the null. There is strong evidence the mean engine life is more than 220,000 miles. And then here's the 95% confidence interval, and we can see 220,000 is not in there. Big thing is to remember, look at your T table. 9 degrees of freedom, 95%, there it is, 2.262 for your T statistic you use as your multiplier there. And so yeah, we're 95% confident the true average life engine would be, our engine life would be 235,000 to about 251,000. Number 3, this is the difference between two proportions. So we're looking at smokers in 2 different age groups. So our null hypothesis is that the proportion of smokers in these 2 age groups is the same. The alternative is that they're not the same. We calculate our Z statistic here, and we found out that they are 1.54 standard deviations away from each other. If we look up 1.54, we get a p-value of 0.0688, and you could double that and actually make it 0.12, but you don't really have to. Either way, it's not significant because we're looking at an alpha level of 0.01. So since p is much larger than 0.01, we do not reject the null. There's not significant evidence the proportions are different. And then a 99% confidence interval, we use for our z multiplier here 2.575, and we get this interval from negative 2.7%ish to about 10.7%. Excuse me. So we're 95 or 99% confident the true difference is somewhere in there, and 0 is in there. So that's why we'd say no, there's not a significant difference, because it is possible there is no difference with 0 in there. Number 4, we're looking at the life or the burning times of 2 types of flares, and they give us all the data here, the summary data. Our null hypothesis is the average is the same. The alternative is that brand X is bigger, they're claiming, or larger, they're saying they have longer burn times. So we actually calculate the T statistic and we get 16.025, which means, again, off the charts. There is 35 plus 40, 75 minus 2, 73 degrees of freedom. If you look up 16, it's really off the chart. So the p-value again here is almost 0. So we do have significant, we reject the null and say we have significant evidence the mean burn time for brand X is longer than brand Y. Type 1 error, we say, yeah, brand X burns longer, and it really doesn't by rejecting the null. Type 2 errors, we don't reject the null and say, nope, there's no difference, but there really is. And then here's the 95% confidence interval. The toughest part was to figure out how many degrees of freedom, and we use 73, so actually we should go, we don't have 73 in our table, so we could go up to the one above that, which is 2. I also accepted the 1.992 or whatever as well. So our 95% confidence interval is between 3.7 and 4.8. So we'd be 95% confident the true mean difference in time is somewhere between 3.7 and 4.8. I think that's minutes. That's what the measurement was. Yeah, minutes. And then number 5 is the dependent sample. Our null hypothesis is that there will be no difference. These are the gymnasts that get, they get a score before, they do some training, a special training, and then they do some after, see if there's a significant difference. So the alternative is that the mean difference is going to be greater than 0. We get a t-statistic of 4.6, and if you look in row 6, that's definitely less than 0.005, very rare. So since we have a low p-value, much lower than 0.1, which was our threshold, we reject the null and say we do have significant evidence that the new technique does raise the average scores, and there's a 90% confidence interval, and we get this 1.943 again from our t-table using row 6. So we are 90% confident the true increase is somewhere between 0.09 and 0.22. And then if we go to the last problem, it says this is the loud music one. There was evidence, which means there was significant difference. That was at the 0.05 level, so that means our test stat was somewhere left of 0.05. So would they have made this same decision if alpha would have been 0.1? The answer is yes. Yeah, it's still going to reject the null, say it is significant. And then they ask, would you make the same decision at 0.01? The answer is maybe, because we don't know exactly. All we know it was below 0.05, so we don't know if it was below 0.01 as well. So it could have been to the right and it could have been to the left. So that's where we get the maybe for that one. So hope this video helps you prepare for the final or test in the next semester.